You are welcome to Electrohive Research Institute of Technology. My name is Yakubu Mohammed. I'm making this video to share all the information I've had in the course of designing my pure sine wave inverter. The first card I used was the AGS 002. This is a Chinese board that generates SPWM. SPWM is sinusoidal pulse width modulation. There are a lot of electronics devices I can use to achieve inverter. One is using a square wave generator. You have a PWM generator, and of course an SPWM generator. This is an XPM generator. This I got from the internet, designed by some Chinese folks. First, I want to give credit to these guys. These guys did a very nice work on this chip. I had this for over 3-4 months. I couldn't do anything with it until one day I decided to pick it up from where I kept it, and I built a pure sine wave. I was shocked. I never believed district electronics can be used to achieve sinusoidal pure sine wave for inverter. So I was able to build an inverter from this card, and I was so happy. But like I said, I told a friend, in technology we want more. I needed more, and at some point I realized that the board could not offer me more than I wanted. So I designed my own board. So my first prototype was a direct replica in terms of function to the Chinese board, but you can see it's bigger because I'm using the DIP and actually use SMPs. They're actually using SMDs. So like I said, this is a direct replica of the Chinese board I got, and I had all the functions the Chinese board offered me. I programmed them into my first board. Then I didn't stop there because I still needed more. I built the second board. The second board is not a direct replica of the first board, but it has all the functions of the first board and some other functions are added to it. But as my code begins to grow, as I begin to develop, I needed space. Then the IC I use here, the STM32F103, could not offer me all the memory I needed, so I migrated to the same 103 but with a larger memory space. But that didn't stop there because I still needed more, and the 103, I ran out of space on the 103, so I decided to migrate or upgrade, which I did. I upgraded to the 401 version. The 401 version has more memory space. It has more speed. Like the 103, the speed was at 72 megahertz. Then the 407 runs at 168 megahertz. It has more like over 3 times, or let's say 2 times the speed of the previous one. But like I said, I needed more. That's what technology will always tell us: grow. I needed to grow more. I needed to do more. And at some point, I realized there are some errors I had on this board, which I modified on the next board. What I did was just to add an extra buffer and some transistors to help me with my short through. More like that would help me to prevent my upper and lower MOSFET from coming on at the same time. So like I said, I needed more. I had to upgrade. I went to the next board. Still, I was still using. Okay, this is the first board. I'm using the same. This controller I had here is what I'm using here. But I really didn't use this board for a long time. I quickly switched to this. If you look at them very well, they're almost the same thing, just some few modifications I made. One advantage of this board is that I had all the functions I've had from the previous, and of course more functions. On this board, I've added a zero cross detector. I've added extra memory. There's an extra memory beneath this card where I can save configuration data of this card. I added a display, a UART display. So I designed a UART display. This is a UART to LCD what it does, this is an MCU, picks the signal from serially from this card and it sends it to the LCD. One challenging thing about using LCD is that if you are programming a parallel LCD, there are times the LCD will go blank or it will be showing some jargons. That's because of the AC present. It will interfere with the parallel lines. So I decided to use a serial cable to connect my LCD. Then what I've added LEDs. So if you don't want to use LCD, you can use LEDs. I will be making a separate video on this card alone. This card is actually a full functional SPWM signal generator. I intend to make it open source. Open source means that I'll be sharing everything about this card on the internet. It's free. You're free to download and use. So like I said, on a separate video, I'll show us how this card can be configured, how you can use them to build your inverter from 1 kVA to 10 kVA as the case may be. Once again, thank you for watching our video, and God bless you.